Okay, so I'm using a new board, so the pen works a little differently. I'm still getting used to it. Hopefully I can get it to work as well as the old board. The good news is the new board doesn't seem to be crashing, so that's hopefully going to save some time. Anyway, here we go. The temperature of water in a tub. So temperature is definitely an amount. So this W is an amount. Let's grab a pen here. So temperature is an amount. It's modeled by a strictly increasing. Increasing is probably going to be important. Twice differentiable function W. W is, here's important for sure. Degrees Fahrenheit. You don't want to write degrees Celsius. W is measured in degrees Fahrenheit. Time is in minutes. If time equals 0, the temperature of the water is 55 degrees. I would write something down over here in the amount column. So W at time 0 is 55 degrees. The water is heated for 30 minutes, beginning at time 0. Values of W, these are temperatures. Okay, use the data in the table to estimate W prime of 12. W prime of 12 is going to be the rate at which W is changing. So we're supposed to be estimating the rate at which W is changing. We've done this type before, so I've got a golden note here. So this should look just like what you see on the golden notes, although I've changed it for this problem. So we've got let's clear that off. That's interesting. So this new board, the pen won't hover and just show what I'm pointing at. So that's a bit of a disadvantage. I have to actually touch the board, but that's okay. So we're right here. So this means instantaneous rate at which the water temperature is changing. We approximate that by just looking how the water temperature is changing near time equal 12. And so the water temperature at time 15 is up here, 67.9. So we write on our paper W prime at time 12. It's approximately 67.9 minus 61.8 because this is telling us how much the water temperature is changing over the 6-minute time period. We divide that by the 6-minute time period. Let's see. Use data to estimate this, show computations using correct units. We need to have the units here. So this is a change in temperature in degrees Fahrenheit. So that's going to be degrees F divided by the time, which is in minutes. So if you have this box on your paper right here, you'll get 1 point. Then they ask for an interpretation, so we just have to write that out in English. So we say the water temperature, this is where the pen is a bit of a problem here. Water temperature is, this would be an increase. We don't have to work this out. If you did work this out, it turns out to be 1 point, use your calculator, 1.017 degrees Fahrenheit per minute. So I suppose this is an example of where, because I have to write out what it means, it is a little bit easier to have that computation. So the water temperature is increasing. I have seen AP tests where if you didn't use the word increasing, they didn't give you the point. So even though the word changing is correct, I do want you to identify that you see that there is an increase occurring. So the water temperature is increasing by 1.017. This board is a little bit of a problem. Degrees Fahrenheit. Increasing by, this should be by approximately. The board's kind of messing me up here, because it's not increasing by that exact rate, but it is increasing by approximately this many degrees Fahrenheit every, or per minute. Per would be fine. But we have to mention, when is this occurring? So this is occurring at T equal, good grief, the board here, T equal 12 minutes. If you have the green statement, you get one more point. So it's 1 point here for the green, and there was 1 point up here for the purple.